Well, good afternoon, everybody, and welcome along to this month's session of DBA Fundamentals Down Under. My name's Warwick Rudd, and I'm your host again this month. For this month's session, we've got Hamish Watson coming to us, talking to us about DevOps and the DBA. Now, I will hand over to Hamish very shortly, but before I do just have some housekeeping to run through. So first up, just need to make a big call out to our sponsor, SentryOne. Without SentryOne, it would make it difficult for us to put on these sessions for you guys each month. If you haven't already been to SentryOne's website, make sure you go there. They have some fantastic articles, videos, and downloads available for you to assist with your learning in the SQL Server environment. Now, coming up in a little over a week's time, if you haven't already registered for it, there's still time to register for 24 hours of pass. As you can see here, it's on from the 19th to the 20th of July. What that gives you is that it's a continual rotation of different speakers giving different sessions over that 24 hours. It's a great event to be a part of, and you'll learn and listen and hear from many different fantastic speakers globally. Now, at the end of the year, we've got Pass Summit coming up. There's still time to register. If you use, we haven't got it up on here, but next month we will have a discount code that will allow you to save even further money on your registration. We've got until the 23rd, so a little over or a little under 2 weeks before the price goes up again for your Summit tickets. Make sure that you get your tickets now, and hopefully I might see you in Seattle at Summit. Now, today's session is being recorded and will be available on the DBA Fundamentals archive site, probably within the next 3 to 4 days, depending on how things go. So feel free to come back and see this session and review it again in the future. So with that, I'll now hand over to Hamish to take us through today's session.
Alrighty, thank you very much, Warwick, and welcome everyone. Alrighty, yeah, welcome to the session, DevOps and the DBA. My name is Hamish Watson. I am in Christchurch, New Zealand, so that does mean I have a wee bit of an accent, but I will try and talk slowly on a subject that I'm very passionate about. Been working in IT for quite a few days, and I've been managing SQL Server since SQL Server 2005. At Jade Software, I'm Operations Manager, and what that means is that in keeping with DevOps philosophy, all my operations staff go on a development course because they're going to be working with developers closely, and I want them to be able to speak the same language as those developers. So yeah, they go on a development course. I'm a leader of Data Platform User Group here in Christchurch, and I'm a frequent speaker both in Australasia as well as around the world. And in fact, I'm lucky enough to be speaking in India in August this year on this particular subject. Forget all that, these are the most important aspects and what you should take away from the slide. So, what are we going to do in this session? I'm going to introduce DevOps. I'm going to introduce some of the tools that we can use for our databases and applications. I'm also going to talk about continuous delivery, and I'm going to bring continuous delivery to a database via a live demo, the bane of every speaker. Right, so what is this thing called DevOps? Well, there's an official Wikipedia definition, that is, if you believe anything that's on Wikipedia. And basically, in the past, developers wanted to release awesome new features to the masses and see them take off in a big way. DBAs like consistent availability, which is threatened by all these changes. And so DBAs and operations people don't want features that are going to break things. And so, yeah, we had this power struggle with DBAs trying to put the brakes on as many releases as possible, and developers were looking for clever new ways to sneak around the process. And what compounds us even more is that our industry is full of buzzwords and trends. You know, this week it's cloud, next week it's gamification, and we're going to be talking about DevOps. So, what is DevOps? Well, it's the ability to safely and quickly get changes into prod. And these changes need to be deployed in a sustainable way. There's no point getting them safely and quickly to prod if we have, you know, 10 people huddled around computers trying to do things manually. We want the deployments to be predictable, reliable, and routine. And the way we do this is through automation. This is one of the cornerstones of DevOps. And the deployment should be able to be performed on demand. And so the way we achieve this is by ensuring all of our code, be it application code or database code, is always in a deployable state. So even in the face of teams of, you know, tens, hundreds of developers making changes on a daily basis, we want it in a deployable state at all times. And so we completely eliminate the integration testing and hardening phases that traditionally followed dev complete, that developers base the success of their code on. So my definition of DevOps for the company that I work at and with clients that I work with is around continuous operations. And I had a rule when we first looked at DevOps. The first rule of DevOps is never say the word DevOps. And the reason why I decided to do that with my company and clients is because so many people have an idea and quite strong opinions about what DevOps is. So we decided to focus on things like continuous integration, right? So continuous integration is merging all the code from developers into a build server and packaging up a standardized package that we can then deploy through to our relevant systems. Part of that is testing. We need to do continuous testing. So we looked at what testing we were doing. It was mostly manual, and so it didn't always go the way we wanted it to. So we looked at automating our testing, which then fed into continuous delivery. And what we'll do in this session is go over continuous integration and continuous delivery. Continuous delivery is about having automated, repeatable, reliable deployments of our code through to production. And part of this is around continuous monitoring. We want to be able to scrutinize performance all the way through our deployment pipeline. So continuous monitoring is a fantastic principle and process of doing that. And one of the things we found is that as we realized some of the efficiencies of these other continuouses, we started baking in security from the beginning. So we started pen testing our build systems, our functional test systems, right the way through, so that we didn't get, so that we weren't testing our prod system, right? So we didn't find out anything there. We found it far earlier. And one of the main things that ties all these together is around collaboration, communication, and what I call chat. And this meant that we all communicated about what we were doing, how we needed to do it to achieve the goal of, you know, repeatable, reliable deployments to prod. Okay, so the database development cycle. This is typically manual. You know, the testing is manual, the deployment is manual. It's inconsistently tested because, again, it's manual. And one of the things that we found was because the testing was inconsistent, we had a fear of changing the database. You know, we didn't want to automate the deployment because we were worried things would break. And we were plagued, and some of our clients were plagued with poor or in fact no source control. And as I'll talk in the session, source control is paramount. If you don't have source control, you need it. You won't survive in the fast-paced industry we're now working in if you don't have some form of source control. And your source control is, consider it the source of truth. Your prod system should be reflected by what is in source control. And we were slowed down by lengthy processes and at times very daunting deployments, because as databases got large and complicated, we were unsure of what was going to happen in prod. So something had to change. And I'm sure as DBAs, we've all had this, where application code was breaking the database, and database is extremely important. You break that, you have no data. And so the developers had their processes, DBAs had our processes, and by being siloed, by having this power struggle, things were breaking. So let's talk about continuous delivery. So some of the principles are around building quality in, because it's much cheaper to fix the problems and defects if we find them immediately. Part of continuous delivery is around working in small batches. So this is where instead of having, you know, a massive waterfall type approach, we're being a bit more agile. We're breaking things down into smaller sizes, iterative deploys, because it reduces the time it gets to get feedback on our work. You know, it's easier to triage and remediate problems, to fix them, if we're working in small batches. And the other part of this, and the key part of continuous delivery and DevOps, is around automating things, because computers do repetitive tasks quite nicely. Humans, we are not very good at doing repetitive tasks. You know, the phone goes, email comes along, and suddenly we've forgotten really what we're doing. And a lot of people actually think that automation is going to put them out of a job, where this is not true. There will never be a shortage of work in a successful company, right? Your company's going to grow because you're doing things better. And in fact, we had 4 testers. We automated the testing, so we didn't, and we went down to 2 testers. We didn't lay the other 2 off. They became developers. They went and did higher value tasks, right? Not that a tester is not a high value task, but it enabled us to grow in other areas by automating things. And we want to relentlessly pursue continuous improvement, because we don't want to be complacent. We want to look at things. We want to improve the process as we go along. And what we did was we started small and then grew. And so that growing allowed us to continually improve our processes as we grew. And this is the other one. We don't say that something is somebody else's problem. You know, developers are responsible for the quality and stability of the software they build. Operations teams are responsible for helping developers build quality in. And so we work towards achieving our goal, which is reliable, repeatable, automated deploys to prod. And so what that means is that the end result is everyone is working together, communicating and collaborating. Right, there's no point doing anything unless there are obvious benefits. And so one of the key ones is enhanced customer experience, because if production deploys are working, if the applications and databases are in a state that are more stable, reliable, customers love that. And you know, they pay us to develop software, to deploy database code for them. And by using some of the principles of DevOps and through continuous delivery, it means that we can react and adapt to enhance our customer experience far faster than the competition. And that means our customers are going to be loyal, they want to do more things with us, i.e. pay us. And it allows us to grow, and by reducing waste and rework, means that we can shift resources to higher value activities. It means that our developers are not up at 3 in the morning, our DBAs are not up at 3 in the morning trying to fix a deploy that went wrong. The deploy worked, people are either asleep or doing better things at 3 in the morning than trying to fix a deploy that was manual and broken. And all of this comes about to give us faster time to value. It means that we can get things out the door quicker, and what we do get out the door quicker is far more stable and reliable. Right, the first part of this is continuous integration. And so what we have here is the developer writes code, they commit it up into our source control system, and at the same time, another developer might write some code and commit it up to source control system. That'll then have a trigger over to our build server, which will have a service that will look at source control, pull the code in, and start doing testing. And what will happen is we might have a build failure, and excuse me, that means we get immediate feedback to the developer down the bottom. And so what they'll do is they'll remediate it immediately. We'll do the commit up to source control, and then we'll do our build, and further down the track we'll do the deploy. Right, so continuous integration, let's talk about it. Continuous integration is a development practice that requires developers to integrate code into shared repository, i.e. source control, several times a day. And I took this quote off a T-SQL Tuesday. If you don't look at the T-SQL Tuesday blogs, you should. They're so valuable to read. And the key thing about continuous integration is you need to do it continuously. So what we have here is a system that in source control, when we compare the branches, it's 6,960 commits behind and 32 commits ahead. This is not continuous integration. So I've bolded the words because we want to integrate our code several times a day. The reason being is we want to merge it, verify it as soon as possible, detect problems early, fix them, and move on. Unfortunately, CI isn't the whole story for reliable deployments. And what happened was we were doing CI, but we were banking up our deploys for say 3 months before they hit UAT. And so what was happening was we'd then deploy through to production, and of course something went wrong. And so we then had to diagnose and triage 3 months of changes. And you know, I can't remember what I did last week, let alone 3 months ago. So whilst we had the benefits of CI as we deployed out, we weren't realizing the full potential. So continuous delivery is about the shift left principle. And what this is about is that we develop and test against prod-like systems. So here we have a CI and build environment that we've done continuous integration, we've deployed to immediately. We may deploy 10 times a day to this, and we get immediate feedback. And then, as things go on, we'll then deploy up to higher level environments. All these environments are what we call prod-like. They are a cut down version of our production system. And what it means is that, again, by deploying in small iterative batches, we can find out immediately how things will react. And so some of these systems, like the integration system, the UAT system, we might actually spin those up in cloud services like Azure, because the thing with a prod-like system, it does not have to have all the code, all the prod code. So your production system might be 1 terabyte, but these might be 50 megabytes. The key thing is that the schemas, the structure, the services that are set up in and around these are the same as prod. And that way, when we do actually hit our prod server via, say, a pre-prod or a staging environment, we know that it is going to work because we've found out all the issues earlier on. And so this allows us to have repeatable, reliable deploys. It enables operations to see early in the cycle, operations DBAs, how the environment will behave supporting the app. And it actually allows us to see how the deploy will actually finish. And we're going to test the whole way through as well, so that any gotchas we're going to find out. And again, we're going to monitor the whole way through the deployment process so that we get early warning of operational and quality issues. And this is what it might look like pictorially, right? So our CI environment or build environment, dev environment, whatever you want to call it, is on 4.0, but as we had deployed 3.5 out. Now, we have deployed to CI continuously after every merge to our master or main or release branch is put into CI. This means that we don't have to deploy 3.6, 3.7, 3.8, 3.9 all the way through, because we will have tested that further down the lower environments. So to do DevOps, you need to consider some things, and those are excuse me, tools, process, people, and culture. We're technical people, we love tools, but tools will not get you there. If you are focusing just on the tools, you will fail, because we need process. And excuse me, the process that we found was that our process was largely manual and disjointed. Things were copied from here to there, configuration and changes were done manually, and thus pretty much done wrong. We had great tools, but our process was lacking because we needed to have the right people. We all needed to be involved in this. And the thing that underpins us is culture, because this is the partnership of our teams, right? And there's a saying that culture always trumps process. And what you want to do is start small, because, you know, DevOps is not just about tools, it's not about process, and it isn't just about culture. And there's another saying I like to have is the tools are easy, but the process is wrong because the people don't buy into or get the culture. Right, there are quite a few tools out there, and tool choice is going to be a complex topic, and one of the things I suggest is that you start small. Spin up a small sandpit environment. Start small and you will achieve greatness. If you try and do everything at once, you're going to fail and get disheartened. And part of this process is working together. Some of the tools that we had, the developers liked, and there were tools that operations DBAs liked. And so we worked together to find a process that was efficient and would achieve the goal of automated, reliable deploys to prod. So here are some of the tools that we use. Yours might differ. We need to have workflow. We need to have source control. We need to be able to develop, and we need automated build server for CI, automated testing, again, and continuous integration, and an automated release process. So this is one set of tools if you were going into the Microsoft stack, but this is the real world. So you may actually use a combination of other tools, and that's okay because it's your process, right? It's what works best for you. And that's one of the good things about DevOps. You could do DevOps with PowerShell and command line, right? It's about the process. It's about having reliable automated deployments. Okay, infrastructure as code is a game changer, and it underpins everything that we want in a DevOps pipeline, because by taking the human out of the equation, it means that we can start spinning up resources, and in this case we're spinning up a VM. You know, we're using Azure PowerShell, And by using infrastructure as code, we are using a process that is declarative, reusable, it's automated, and testable. We can test all this out and then roll it out, and we know that we're going to have a consistent build. And by automating through infrastructure as code, it actually allows us fast feedback, because our developers can spin up environments at the touch of a button. They can get things deployed, stood up, and get that feedback immediately. And so developers can run up their own resources. DBAs can run up their own resources. They don't need to engage with humans who sometimes are inconsistent. And so by being able to provision, spin up, tear down at the click of the button, it means we can increase our velocity of finding out things. But a key thing is configuration management, because it's no point just installing things, using PowerShell. We need things like desired state configuration. If you are not using PowerShell, you need to, because you will become the COBOL developers of 2017. The world is moving towards PowerShell. But just as important is a thing called desired state configuration. This is where we can detect drift. This means that the resources that we've spun up, we can now look to see what packages have been installed since it was spun up, and we can automate all this. And we need a repository of configurations. And by using these, it means that no human is going to, click next, next, choose this, choose that, because again, humans are a little inconsistent. The computers can do all the work. There are products out there that can help us with this, Redgate, Chef, Ansible, Vagrant, Puppet, Octopus Deploy, and VSTS, and Team Foundation Server. So these products can allow us to manage our configuration, to be able to declaratively configure the software or things on our servers. Right, so what can we do to bring about database change? Well, there are such things as ORMs, SQL Server Data Tools, or SSDT, and the resultant DAC packs. As I mentioned, PowerShell is so powerful. And source control is paramount. We want to tie our database changes in with our app changes. And here's the deal. In source control, we want them to be peers. We don't want database code to be a child of application code. We want them to stand on their own and be deployed on their, together. Source control is kind of like breathing air. If you don't have source control, it's like breathing dirty air. You won't die, but you will get sick eventually. And so by having source control, it's like breathing clean air. And standards are mandatory. We want standards because, automation is built on the foundation of standards. Right, so let's quickly talk about ORM. It's a dirty word to some, but it has its uses. It can speed development in certain cases. We can build business rules. We can build business rules into the data access layer. It also makes data access more abstract and portable. And it generates boilerplate code for basic create, read, update, and delete operations. But be careful, because you can write horrid code very easily. And look, some people vehemently hate ORMs like Entity Framework, and they say, oh, you can't have stored procedures in them. Well, you can. It's just a different process, and you still need DBAs to work with code-first developers, and that again is the premise of DevOps. We're working together to achieve the goal of reliable applications. So let's go back to what we all love, is SQL Server Data Tools. Firstly, this was first brought out as data Dude in 2007. It was called Visual Studio Team System Edition for Database Professionals, hence why it's called Data Dude. And this was all about helping developers use their familiar and comfortable Visual Studio environments while allowing integration of database development into, you know, application lifecycle management. And so SSDT is basically the evolution of Data Dude, because three things occurred. Data Dude proved to be very popular. Visual Studio was more integrated with SQL Server data tools, and SQL Azure came along. So, yeah, SSDT came along with SQL Server 2012 onwards. And basically, Microsoft have summed it up well. It's for database developers who often develop, you know, schemas, views, stored procedures, and other database objects whilst developing their application logic. So is it a replacement for SSMS? Not really, because SQL Server Management Studio allows us to do core administration, you know, creating, managing backups, and all these things. It's about online instant management, whereas SSDT is around development. And there's a couple of ways that we can deploy SSDT resultant DAC packs, and DAC packs allow us to, SSDT allows us to develop database changes as code. It allows us to commit those changes to source control, because we just want files in source control. We don't want the whole database in there. And it allows us to push the DAC pack out to dev databases and or our CI build server. And the game changer was we could now deploy to on-premises databases or up into Azure. And there's a couple of ways of how we can deploy them out using SQL Package, our very good friend PowerShell, even in Management Studio, as well as some APIs. So, using DAC packs in our continuous delivery pipeline, we're going to utilize the shift left principles of continuous delivery, because we're going to have a consistent build right the way through, and it enables us to backfit prod-like environments. So we may start off with a prod system and we want to create, you know, 4 lower environments. Well, DAC packs allow us to do that. You know, we only want the schema, the structure. We don't need the data in some cases. And if you get a chance, look up Kent Chenery on Twitter, or just Google Kent Chenery and SSDT CI/CD. He writes a really good blog that shows you how to implement SSDT into continuous integration and continuous delivery. And here's the thing, we need DBAs more than ever. Some people say, oh, with DevOps, the DBA is dead. No way. The role will change, right? The DBAs who understand automation, the DBAs who can do scripting, who can take complicated multi-tier environments and break them down into smaller systems and understand that, are so valuable. And, you know, this isn't unicorn magic. You know, some people say, oh, DevOps and database, it's just for unicorn companies, it's for people that write web apps. No way. Here's the thing, what is a unicorn to you, to me, is just a drunk donkey wearing a party hat. So it's all about perspective. Right, I've done enough talking, because I'm now going to show you this in real life. So let's have a look at what I've got is a application, a website here that interfaces with some databases here. So these are all up in Azure. We have a CI database, a functional test database, and a QA database. And so what I'm going to do is show you the interaction between this app, which is in CI. We have one in QA, which it is at version 109. Our application in CI is at version 124, and you will notice that this says SQL Saturday Brisbane. So what we do is we have a solution that I have here, So we have our application code for the web app up here, and using SQL Server data tools, I have the database stored as code, and you'll notice that they are peers. So the DB is not under the web app, and we also have some application tests. So what does the code look like? So this is the structure of my table, again, as code. And what we'll do is we can, you know, build and publish our database from code. So what I'm going to do, I'm going to do two things. We are going to add a table, because I've been asked that for the DBA fundamentals virtual chapter, we need a table. Excellent. So I'm going to add a table. And so it's going to be pretty small. But what I'm going to do is chuck in some code. And now we have the resultant table. And so I will save this. And what we also want to do, and this is where during the same time the application developer may come along and they're going to do this, and they're going to change this to DBA fundamentals VC. And so they're developing you know, independently of me. So here's our solution, right? So I've created my table. So let's have a look at the structure up in Azure. So we have some tables, and you'll notice that we don't have the fundamentals one there. And the cool thing about our databases are they are consistent because they've been generated from the same code. But what we have here is a database that I've just spun up, and it does not have any tables. So what we'll do is deploy to that. But this, so we are developing here, but we need to have source control. And so what we have is our source control is up in Visual Studio Team Services. And so we will push up to source control very soon. And what that looks like is in Visual Studio Team Services, this is the online versions of TFS, Team Foundation Server. We have our repository up here. So this is the source control for my particular application. And so in here we have all the things pertaining to the app and database. And the cool thing here is we have a history. So as you can see, I did a couple of deploys before. And what we do is we're going to take this, the code here, and we're going to use the build part of VSTS. And this is around doing the continuous integration stuff, right? So we're going to take the code from here. We're going to do the build in here, and then hopefully deploy it out to both the website and our respective databases. So I have some pending changes, hopefully. And so we have our SQL code. We have the code that was related to whatever the web app developer was doing. And so what we're going to do is check this in to source control. Okay, so we'll check that in. Oh. That has been successfully checked in. And if I've done my job right, that's in progress, right? So that's kicked off now. So let's have a look at this. One of the great things about continuous integration tools is the ability to have logs. So whilst this is building, I'm going to show you the steps that we have for this particular CI process. And this again is where developers, DBAs and operations people work together. So this is the process of the build for CI. And so we have a couple of steps in here. We use NuGet as all good developers and DBA should. We're going to build the solution, we'll do some tests, and then we're going to output an artifact. And the artifact is a standard package of our deployable code. And then once it's built, we will then deploy it out. And one of the great things about things like VSTS, TeamCity, Jenkins, is there is so many different things you can do. And so the library of steps is just massive. So today I'm using VSTS, but you could use TeamCity, and there is just so many different steps that you could put in there. You know, you don't have to write your own code. It's already done for you. So hopefully our build has succeeded. Cool, it has. So the next part of this process is the release part of it. And so in VSTS, that's all encapsulated. So we've got a release happening here to our CI environment. So let's have a look at what that might look like. And again, we have different environments that we've set up in Release Manager, and the thing about these is that they are consistent, because we want that shift left principle. And so the functional test environment here will deploy to once CI is finished. And so we can now look at the logs, and what we're doing is doing some of the steps, and so it's actually deployed to our Azure SQL database. So let's have a look, and the cool thing is I can just hit refresh, and we have our new table. So that didn't exist before, so we've deployed this iterative change to our CI environment. So let's have a look at the application side. Oh, that's still going. And again, we have the ability to add in, add in tasks as we want. And again, those tasks are, you know, there's so many different things you can do. You know, you can run scripts, you do command line stuff. So yeah, for us, this was a really good thing to have. Right, so we've deployed to CI, so let's hit up our CI website. So hopefully we'll have a different number. 125 would be good. And while that's spinning up, what we'll do is let's deploy to a completely blank system. So what we'll do is deploy to that, and again, if we look at our functional test database, we have nothing in there. And so what will happen is the deploy once it kicks off, it'll do all the, it will take our DAC pack that was the resultant part of the code that we had written for our database. It'll take the DAC pack and deploy it out. Now here's one of the great things about SQL Server Data Tools. If I connect to a local SQL Server instance on my PC, I can actually publish this to my system here, right? And what I'll do is follow some form of standard, and this might be dev. So I'm actually backfilling my system to my PC here. So, oh yeah, here we go. Publish completed successfully. So if I right click, I now have a system here that is a mirror image of what we have up in Azure from the same place, right? So again, that prod-like scenario where all databases have the same structure, schema, everything, all using SQL Server Data Tools. Now, I could have done this using Entity Framework, and in some demos, I actually do use Entity Framework, but I prefer to use it here. Now, unfortunately, for a new database, it does take a wee while in Azure to spin it up because there's so many checks that we have to do. So while that is occurring, I want to show you infrastructure as code, because the key thing about this is that we can spin resources up as required, you know. So I can parameterize all these resources that I want to spin up and test things as I need to. So what that will do is I have a couple of databases here in Azure, and with my PowerShell script, I'm going to spin up some databases and some app services. So if I look in app services, I have 3, and soon I'm going to have more databases in here and more app services. And that's still going. Okay. What I may do, because the internet is slightly slow, we may leave this for now. But what I will do, I will just show you one thing, and this is the beauty of good release management tools. The ability to clone our environments or our deployment steps, and you know, being able to do it with one click, set up some, you know, how it will deploy. And you will have noticed that before, the CI environment deployed automatically. And the point of that is I don't want human intervention. I don't want us to have to go in, click things, especially for CI, because this is going to be deployed to, you know, a lot during the day. And we do, oh, here we go. We've got our 2 databases, our system integration test one and our train one have popped up. And what was once 3 is now 4. So yeah, being able to spin resources up at the click of a button is fantastic, and is the name of the game. Right, so let's see how our deploy went. Oh, cancel. I don't want to save that. Okay, fine. Okay, so it's finished. Right. So this is QA. If I hit FT, which did not exist, that'll spin up. But more importantly, with database people, how did our database go? Boom. Alrighty, let's get back to the presentation. So, game changers. Infrastructure as code and configuration management. If you're not, you know, declaratively writing software to spin up resources, you're doing it wrong. Source control for all database and application activities where possible. The goal is reliable automated deploys on prod-like systems. Having consistent databases and applications right the way through is paramount. Obviously, we want to change them, but we want to change them iteratively and find out all the mistakes way early. We want to fail quick in CI or build environments, because we want that immediate feedback. And if I fail in a continuous integration, small little database and app, that doesn't hurt anyone. But if I fail in prod, that hurts. So let's celebrate lots for those really boring prod deploys that just work. And utilizing cloud services, being able to spin up resources, tear resources down as required. And communication, collaboration, and culture. I'm sorry, but you have to buy into the culture. Without culture, you're dead, because the tools might be right, but the process fails because the people don't get the culture. And you know, by collaborating, we're collaborating about infrastructure as code, right? So DBAs need certain things, developers need certain things. We don't ever want to do manual things. We want to automate everything. We want to be able to declaratively build things. And don't underestimate the difference between database and application. And as I said before, experienced DBAs are integral to achieving our goal. Automation is cornerstone. And again, the culture will underpin everything. So with that, I've talked a fair bit. I've hoped that my demo shows you some of the good things you can do with certain tools. Today I use SQL Server data tools. As I say, I could have used Entity Framework, or I could have used you know, Redgate tools or any other tools. It really doesn't matter too much what the tools are, so long as the goal of, you know, automated scriptable deploys, that we can do those. So if there are any questions, Warwick, I'm happy to answer them now.
Okay, so Hamish, we do have a couple of questions. Yep. So when building / deploying to a target server, does it revert any changes that a prior deploy would have made that is not in your current branch of the project, i.e. deploys from an unrelated branch? If so, is it determining changes to apply by comparing the existing physical DB structure to the structure defined in the project being deployed?
Whoa. Okay, that is a huge question. Okay, so part of continuous integration is around merging. So we might split off a branch into, say, a feature branch, or even a hotfix branch. And so what we'll do is merge that in to the branch as soon as we can. We will deploy to a lower level system, say a CI build functional test system, and we will detect what changes we have to do. Now what you can do with, there are two approaches, right? So you can do the model state, or you can do migration based deployments. So yeah, so you can do model driven or migration based. What we might do with SQL Server data tools, you can do pre-deploy and post-deploy scripts that again you can feed variables in, and so you may have a case where you want to either rename tables or you know, export data out of a table into another table, and you may need to do that during the deploy process. By having those standardized prod-like databases right throughout the deployment pipeline, we can find out those things. And any merging that we're doing with branches and source control, because you know, we want to branch, you don't want to branch off too much. You want to keep your branching, you know, as efficient as possible, because merging back into your main or release branch, you know, it's not the, it can be straightforward, and it can be a very complicated process, and that's why we want to do iterative changes, merge as soon as we can, find out what breaks, what succeeds, and then move on from there.
Okay. Can you elaborate and suggest what a government-heavy organisation will achieve this speed?
Yes, they will save taxpayer money. Okay, I'll answer. By the way, that answer is truthful. A government-based, department, what have you, will have very strict rules. So that's why I say if you're going to have prod-like systems, you cannot have the same data all the way through, because obviously there are regulations around data leaving a prod system. So you may either anonymize, strip data out, what have you. The key thing here is, even if you're one of those monolithic government type departments, and I apologize to the person if I've just offended you by saying monolithic, is that the process is still the same here. You want to make your end deploys as stable as possible, so that you're not having to have people tied up trying to fix problems in prod. Let's find out those problems early when we can remediate them as soon as. On a small little build functional test system, who cares if we break something in one of our testers, or our automated testing breaks, fails, what have you. We want to do it there. We don't, a government application is the most important thing to benefit from DevOps and continuous delivery, because if it breaks, it makes the newspapers. Your CI and build environment that broke won't make the newspapers. Yeah. So, and again, you'll save taxpayer money by having efficient deploys.
Okay, so what is the best way to handle reference data in continuous deployment?
Reference data. Okay, so you could actually have, now if you have, did you say consistent data the whole way through?
It just asked for the best way to handle reference data in continuous deployment.
Okay, so you could have that data in source control and then just deploy it out as required. It could just be a peer folder, and you say, right, this reference data needs to be in all of my SQL Server-based systems. Good as gold. It could be a CSV that we deploy, right? And any good continuous delivery tool like Octopus Deploy, VSTS, even Jenkins, could pick up that CSV file of reference data and deploy it. The key thing here is the deployment of that CSV of reference data will be standard the whole way through. It will be consistent. We know that if it deployed in our build system, it will deploy through up into, say, pre-prod or staging. And heck, if we want it in prod, so be it. There is a step in VSTS about deploying SQL scripts, right? Inline SQL or a .SQL file. Cool. It's again that consistent deploy of code, of scripts, what have you. So it's possible. Very possible.
Okay, so one more question. How can you handle exception configuration only found in particular environments like CDC or replication? Is that part of a DAC pack?
Oh, okay. Yes, it can be. And again, the DAC pack, you can have pre and post scripts in there that again will be deployed out consistently. I guess one of the things I'd be worried here is that the word, I think you used the word inconsistent, was it?
Exception configurations. So only found in particular environments.
Okay, yep, cool. Rule-based deploys, right? So some systems may have, let's take availability groups as an example, and I think that one of my aims is deploy availability group with continuous delivery, right? So our prod system will have AG, availability group set up. Our CI environment probably won't, and so that is an exception. But by tagging particular process steps that we say in prod, do this, in replication systems, do this. And again, it's collaborating. Like, the process is not, you know, fixed in stone. It has to be flexible. But again, it's about collaborating on it. It's about finding out what we need to do. So I really hope that the CDC type stuff and replication, you have at least one non-prod system set up so that you can discover these things there and then remediate it and then deploy to prod and know that it works and that we've identified the exceptions, because there are exceptions. It's not, there isn't a big massive, you know, magic wand or a big green go button. It takes hard work, but it's constructive hard work and it will make your life easier. Our time in lieu went down. So for the government person who asked, time in lieu for my company went to almost nil. We had massive time in lieu because people had to work weekends, people were working at night. We didn't have to do that anymore because with working hard, doing proactive stuff, we minimized and almost eliminated the reactive stuff. There are exceptions, but you work around them together. Developers, DBAs, operation, infrastructure people, testers, the whole shebang. Even business analysts, God forbid. Yeah.
Okay. If there's no more questions, well, we've just had one quick one. Thanks for reminding us all DBAs still value for their new architecture, AWS, Azure, SQL 2016 still need us.
Oh, I tell you what, this is an exciting time to be a DBA. It really is. The thing about being a DBA now, and because this is based in Australasia, everyone should get this horrid joke that I'm going to say. I consider DBAs will become more like squirrels than koalas. Koalas do one thing and one thing well. They eat eucalyptus leaves. They're pretty much the COBOL programmers of the animal world. You take away the eucalyptus leaves from a koala, it'll die. You look at a squirrel, it's a generalist. It does one thing pretty well, it stores nuts. But it adapts, and we all have to adapt. And Azure, AWS, infrastructure as code are things that can enable DBAs to become better. Because here's the deal. You spin up a database consistently, what are you going to do with the time that you used to spend? You know, spinning up a SQL server used to take me 4 hours of manual clicking. It takes, you know, 30 minutes, or in Azure it takes a minute, 1 minute. Well, now I can go read Brent Ozar's blog posts on index tuning and make the database a better thing. We need more experienced DBAs. It's exciting time. It really is.
All right. So with that, thank you to everybody for coming along and being part of this month's session. Thank you, Hamish, for coming along and presenting to us and talking to us about DevOps for the DBA. Next month's session is already available. So if you haven't already registered, please make sure that you go to the DBA Fundamentals website, register for next month's session, and I look forward to seeing you all again in a month's time. Thank you.